Good evening, everyone. Today, we're going to tackle about greatest integer function. Our learning objectives for today is at the end of the lesson, students will be able to solve and graph the greatest integer function with at least 90% accuracy. But before we proceed to our main topic, let's have a review first about quadratic reciprocity law. So, quadratic reciprocity law is a powerful result in number theory that helps us figure out whether a number is a square modulo a prime number. Quadratic reciprocity helps us decide if one prime is a square mod another. You can flip the question, switch the primes, but the sign may change depending on the values. If either prime is 1 mod 4, the result stays the same. If both are 3 mod 4, the result flips.
For your pre-activity, instruction for each of the following numbers, what is the nearest integer that is less than or equal it? The first one is done, so you need to continue the following numbers. This activity actives your knowledge of roundings and prepare you to understand the concept of greatest integer function.
Let's proceed to greatest integer function. So, what is greatest integer function? Anyone? Okay, so the greatest integer function is also known as the step function. It is a function that gives us the greatest integer less than or equal to a given number, or denoted as n is less than x is less than n plus 1, where n is an integer and x can be any real number, irrespective of what number is being set as input to the function. The output is always an integer.
Okay, so example number 1, which is the x integer. So state that if x is an integer, then the value of the input of the function is also the same value of the output, which is the greatest integer function. So here, if we have an input integer which is 4, so our greatest integer is 4. Very good. How about if we have input integer which is 10? The greatest integer is 10. Very good. How about if we have negative? If we have input negative 7, is negative 7 an integer?
Yes, ma'am. Yes, ma'am.
Okay, very good. So, our greatest integer of this function is also
Negative 7.
negative 7. Very good. So, how about if we have negative 2? Is greatest integer is also
Negative 2, ma'am.
negative 2. Very good.
So now let's proceed to another example. X is non-integer or in decimal form. So it states that for a non-integer input, the greatest integer is simply the integer immediately to its left on the number line. So example, we have here an input of 1.6. So the greatest integer of that function is equal to 1. Why? Because if we're going to graph that function, the left value of that function is 1. Okay? So you can see our the left value of 1.6 is 1. So that is that is the greatest function integer. Okay? So for example number 2, we have our input negative 2.3. What do you think is the greatest function integer of that function?
Negative 3.
Okay, very good. That answer is negative 3. That's correct. Because again, if we were going to graph that function, the left value integer of that function is negative 3. Okay, how about let's proceed to example number 3. We have an input of pi. What is the value of pi?
3.14.
Okay, very good. The value of pi is 3.14. So, what is the greatest integer of that function?
3.
Okay, very good. All of your answers are correct. The value of the greatest integer is 3. Okay. How about our input? If our input is negative 5.6, what do you think is the greatest integer of that?
Negative 6.
Okay, very good, Joyce. Very good, Marian. All of your answers are correct. That is negative 6. Okay, now let's proceed to in graphing. Aya?
Once again, good day to everyone. So today we'll be doing on how to graph the greatest integer functions. So first, let's recall the definitions. So according to the definitions, the greatest integer function is denoted by y is equals to x, where if the value of x is an integers, then we will not be changing anything. Therefore, if x is integers, then the value of x will be the same value of our x. But if the value of x is a decimal, then we will be rounding off to the nearest, round down to the nearest integer. Let's say for an example, if the value of x is 2.7, so we will be round down to the nearest integers, that would be negative 3. So let's say that according to our example, we have here the examples. To graph the greatest integer functions y of x, we have to substitute random values for x, where x is equal to negative 3, negative 2, negative 1, 0, 1, 2, and 3. So what we're doing now is we're just going to substitute the value of x from our formula. So y is equals to x. First, y is equals to negative 3, right? So this one, we're just going to substitute. That is equals to negative 3, where it implies that our ordered pair is negative 3 and negative 3. And in graphing this ordered pair in our Cartesian plane, we can say that negative 3 is here and negative 3 is here. So therefore, it's over here. And in graphing the greatest integer functions, we need to move 1 units from our point to the right. So this is our point. We need to move 1 units to the right. So that we need to move 1 unit to the right, where it ends in an empty circle. So just like that. And next is the negative 2. Y is equals to negative 2 is equals to, that is negative 2, where it implies that our ordered pair is negative 2 and negative 2. So we can say the negative 2 here and negative 2. And don't forget to move 1 unit again. That ends in empty circle, right? Then next is y is equals to negative 1 is equals to negative 1. That implies our ordered pair is equals to negative 1 and negative 1. So negative 1 is over here, and we need to move 1 units from left to right. That is like that. And our 0, next is a 0. That is equals to 0, where it implies that our ordered pair is 0 or 0, or also known as the origin directly. Over here, 0, 0, Then move 1 unit to the right, from left to right, that ends an empty circle. The next one is our positive one. 1 is equals to 1, or is equals to 1. That implies that our ordered pair is 1 and 1. So 1 and 1 can be seen here, right? Then move 1 unit from left to right. That ends an empty circle. We're running out of marker. So next is y is equals to 2. Okay, this is happening. Then y is equals to, that is equals to 2, because we're not changing anything. That implies that our ordered pair is 2 and 2. Then 2 is over here. Then move 1 unit and ends with an empty circle. And the last one is y is equals to 3, positive 3, where is equals to 3. That implies that our ordered pair is 3 and 3. Can be seen here. Then move 1 circles. As you observe in our graph, it creates a pattern where it is like a staircase. That's on how to graph the greatest integer functions.
Okay, for the application instruction, use the greatest integer function to figure out how many pizza to order for a party. Background or scenario, you're planning a party pizza costs 300 each. Each pizza has 8 slices. You want to make sure everyone get at least 2 slices. So I will give you one example, the example A. So have 10 people. So 10 times 2 is equals to 20. Why 2? Because at least 2 pizza slice for each people. So muna siya ang 20 slice needed. So for the slice naman, divide 8 because 20 divide 8 is equals to 2.5. Why 8? Muna siya ang 8 slice pizza. So pizza using floor function, or the greatest integer less than or equal to 2.5 is 2. That our final answer. Okay.